In this video, we're going to find all real values of m and n that are not equal, such that n squared minus m is equal to 49 and m squared minus n is equal to 49. Let's go. We can call this equation 1 and call this equation 2. Now notice that the first equation is equal to 49 and the second equation is also equal to 49. That means the left-hand side of both equations must be equal. That means the left-hand side of the first equation, that is n squared minus m, must be equal to the left-hand side of equation 2, that is m squared minus n. Now let's move everything to one side. So we have n squared minus m. As this crosses, it becomes minus m squared. As negative n crosses, it becomes plus n. And this is equal to 0. Now let's rearrange this equation. So we have n squared. Now I'll take this term with squared. This is negative m squared. So I'll write it negative m squared. Now this is plus n. So plus n. And then negative m. Negative m. And this is equal to 0. Now notice the first two terms of this equation. This is a matrix known as difference of two squares, and it can be written as n minus m times n plus m. That is it. That is just for these two terms. Plus, here we have n minus m, and this is equal to 0. Well, we can also put this inside of a bracket if we want. Now notice once again that n minus m is common. And because of that, we can factorize. So let's factor out n minus m inside of a bracket. Now open a bracket. Now this divided by this, we have this, which is n plus m, plus, now this divided by this, we have 1. And this is equal to 0. So we have two factors, this and this, which multiplies to give 0. That means either one of them must be 0. So it is either n minus m is equal to 0 or n plus m plus 1 is equal to 0. Now for the first case, we can just move negative m to the right hand side so that we have n to be equal to, as negative m crosses, it becomes positive m. Now say something, n is equal to m. But from our given condition, n must not be equal to m. So we're going to reject this. Now let's focus on this. Now I'm going to be moving 1 to the right hand side. So we have n plus m to be equal to, as 1 crosses to the right, it becomes negative 1. And not just that, I would like to make n the subject. So I'll move m as well to the right hand side so that I have n to be equal to, this is negative 1. And as m crosses, it becomes negative m. Very good. Now I'm going to be substituting this in either of the two equations. I'll choose equation 1. This is n squared. Remember, n is this. So I'm going to be writing negative 1, negative m in place of n. And this is squared. So I'm going to be raising this to power 2. Minus m, so minus m, this is equal to 49. Now notice that squaring negative 1 negative m is same as squaring 1 plus m. That is it. So minus m, and this is equal to 49. Now let's square this expression. So this is 1 squared is 1 plus 2 times 1 times m is 2m. And then plus m squared, minus m, and this is equal to 49. Now let's rearrange this equation. I'll start with m squared, so m squared, now plus 2m, then minus m, then I'll write 1, which is plus 1, and I'll move 49 to the left hand side to become minus 49. And this is equal to 0. And now simplifying further, we have m squared 2m minus m is plus m, and then 1 minus 49 is minus 48, and this is equal to 0. We're going to use the quadratic formula to solve this. So what is my a? My a is 1, b is also 1, while c is negative 48. Now the quadratic formula we're using, since we're looking for m is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute here. So we have m to be equal to negative b. Negative b is 1 plus or minus the square root of b squared, that will be 1 squared, minus 4 times a times c. So 4 times a times c, c is negative 48, all over 2 times a, that is 2 times 1. So simplifying further, we have m to be equal to negative 1 plus or minus the square root of 1 squared is 1. And then negative times negative is positive. So 4 times 1 times 48 is 192. All over 2 times 1, that will be 2. Very good. So this gives m to be equal to negative 1 plus or minus the square root of 1 plus 192 will give 193 all over 2. So there are two values of m from here. So m here will be negative 1 plus the square root of 193 all over 2. Or m, which is the other value for m, will be negative 1. Now go with this negative, negative square root of 193 all over 2. Now let's use these values of m to get the corresponding values of n. Now let's recall that from our substitution, we know that n is equal to negative 1, negative m. So to get the corresponding value for n, we'll substitute this m. So for the first one, this will be negative 1 minus m. So the corresponding value, I'll put this inside of a bracket, will be negative 1 plus the square root of 193 all over 2. Now let's simplify. So we have the first value of n to be negative 1. And negative times negative is positive 1. Negative times positive is negative square root of 193 all over 2. Now let's combine the fraction. So we have our corresponding value for n to be 2 times negative 1 is negative 2 plus 1 minus the square root of 193 all over 2. So the final value for our first corresponding value for n will be negative 2 plus 1 is negative 1 minus the square root of 193 all over 2. Very good. Now let's go for when m is equal to negative 1, negative square root of 193 all over 2. So our corresponding value for n, let me say and. So this will be negative 1 minus m. M is, this time I'll put this inside of a bracket, minus 1 minus square root of 193 all over 2. So this becomes n equal to negative 1. And negative times negative is positive 1. Negative times negative is positive square root of 193 all over 2. Now let's combine the fraction. So n will be 2 times negative 1 is negative 2 plus 1 plus the square root of 193 all over 2. Now I'm going to be forcing this here. So this will be n2, which is our other value for n, will be negative 2 plus 1 is negative 1. Here we have plus the square root of 193 all over 2. So we've got all values of n and m. Now, there is something you can also do. Instead of going this long process to look for the corresponding value for n, we remember that our original equation is symmetric, which means swapping the positions of m and n will not change the equation or the results. So instead of looking for the value of n, you can just interchange their results, and that will be it. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up, subscribe if you haven't, turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.